So we've been factoring pretty simply, but when you get into higher degrees, sometimes factoring gets a little more difficult. And so you can use division to help you determine if something is a factor. The first way we divide is just straight up by long division. While this is something very familiar, sometimes it gets a bit tedious. So pay attention to how I tell you to do this, because I promise I am telling it to you the best way to not make the easy mistakes. All right. So long division is just like you remember it from elementary school. You are going to do your long division sign. You are going to put what's being divided goes on the inside. So we have 2x cubed plus 7x squared. You must have a monomial for every degree. So if you start at x cubed, you need an x squared, you need an x to the first power, and you need something without an x. We are missing our x to the first power. All right, so if you are missing one of your x's, you are just going to put in a 0. So you'll notice I went from 3 to 2, and then I jumped to not having one at all. I have to put a placeholder there. And then I am going to put my minus 15. On the outside, it is what is doing the dividing. What's doing the dividing? I would write it in standard form here. Both of them need to be in standard form. So my first one was in standard form. My second one is not in standard form. So I will rewrite that to be 2x plus 3. All right. And then I'm just going to do my long division. I only have to look at that first guy to decide how I'm going to multiply. So I'm going to say 2x times what gives me 2x cubed? Well, that is going to be x squared. So I'm going to put that x squared over my x squared. And then I'm going to multiply it through x squared times 2x. That is going to give me my 2x cubed, which is how it should always be there. And then x squared times 3 gives me plus 3x squared. You are subtracting. I promise the easiest thing to do is to do adding the opposite of everything, because you will forget you're subtracting. So I always do adding the opposite of both of those, just because you will mess. This is where you'll mess up, is right here in the subtraction. So you have a positive 2 and a negative 2x cubed. Those cancel. You have a positive 7x squared and a negative 3x squared. You have a positive 4x squared. And then you want to bring down the next guy, plus 0x. And then you are going to do this all over again. 2x times what equals 4x squared? 2x, right? So then I'm going to multiply. 2x times 2x gives me that 4x squared. 2x times 3 gives me 6x. Again, you are subtracting. So I always do adding the opposite of each of those. All right. And then you're going to add down. You're going to say 4 and negative 4. Those cancel out. 0 and negative 6 give me negative 6x. And then I'm going to bring down the negative 15. All right. And then once again, what 2x times what equals negative 6x? Well, that is going to be negative 3. And then I'm going to multiply through. Negative 3 times positive 2x gives me negative 6x. Negative 3 times positive 3 gives me negative 9. I am, once again, adding the opposite. Opposite here, opposite here. Negative 6 and positive 6 cancel out. Negative 15 and positive 9 give me negative 6. They do write this with the remainder here. I am always going to have you write it as a fraction. So I'm going to go ahead and teach you that piece of it. The remainder here is this guy right here. When you have one less degree than what you have dividing by, so I'm dividing by x to the first power, and this is x to the 0 power. That is your remainder. You're done at that point, okay? So this is your remainder, but we're going to write it like the good old days when we wrote remainders and made mixed numbers. We are going to put the negative 6 over what we were dividing by, 2x plus 3. Okay, so that's what we're going to do. We're going to do our remainder like you would have done. You know, in elementary school, you started out writing r equals, and then you realized you could put it as a fraction. All right, and that's what we're doing. We're putting it as a fraction. All right, so another way to divide is called synthetic division. They show you where it comes from. You basically do this. They get rid of all of the variables, right? And then they flip it. So they got rid of the x and they just did what happens when you set it equal to 0 pretty much. So instead of the x minus 2, they just have them -2. Instead of the x squared, the x's, right? They just get rid of all the variables. 3, -8, 0, 14. You end up with it looking like this. So it's kind of flipped upside down. You're going to do synthetic division here. You'll notice they took the negative out because it's really what happens when you set this guy equal to 0. So if I am dividing by x minus 2, what makes that 0 is a +2. And so that's with synthetic division, that's what I'm going to use there. Your sign will change, okay? The line up here, those are your coefficients. You'll notice they also had a placeholder here because we did not have an x to the first power. To do synthetic division, you add down and multiply up. So you start with this guy. 3 plus nothing is 3. Then I'm going to multiply up. 2 times 3 is 6. Then I'm going to add down. -8 and 6 are -2. Then I'm going to multiply up. 2 and -2 are -4. 0 and -4, -4, 2 and -4, -8, and a 6. To make this into your answer, you throw your variables back in. I started with an x cubed. This would become then a 3, and I drop it by 1, x squared. So I always drop this guy by 1. Minus, and then I just go down, 2, x to the first power, -4, no x's. This last guy is always my remainder. Right, that is my remainder. And so synthetic division kind of flips your long division upside down. And I personally like it better, but that's just me. All right, so we're going to do one with synthetic division. Let's look at example 2. Use synthetic division to divide 2x to the 5th minus 3x cubed plus 7x squared plus 3x plus 18 by x equals 2. I will say this is usually easier when there is no leading coefficient. Because if there's a leading coefficient, you have to do all this with a fraction, which some people still prefer, which is perfectly fine. And if there's a common factor, you actually have to divide everything by that common factor except your remainder. So it's a little crazy. But you're going to set it up just like this. You are going to say, well, I'm going to use my coefficients. I have 2x to the 5th, so I'm going to put a 2 there. -3x to the 3rd. I have a problem. I went from x to the 5th to x to the 3rd. Where is my x to the 4th? It's not there, so I'm going to put a 0 in its place. Now I'm going to say -3x cubed, 7x squared, 3x, and 18, which, by the way, you have to have a placeholder for that 18 if there was not an x to the 0 position as well, if you don't have a constant. Now, I am dividing by x plus 2. So what's going to go on the outside? Well, whatever makes that 0, okay? Whatever makes that 0. So what makes x plus 2 0? Well, that is x equals -2. So I'm actually going to do this process with a -2. All right? And then I'm just going to go down. 2 plus nothing is 2. Then I'm going to multiply up. -2 times +2 gives me -4. Then I'm going to add down. 0 and -4 give me -4. Multiply up. -2 and -4 give me +8. Add down. -3 and 8 give me 5. Multiply up. -2 and +5. -10. 7 and -10. -3. -2 and -3 are 6. 3 and 6 are 9. -2 and 9, -18, my remainder is 0. To give the actual answer of that division, I need to plug my variables back in. So I'm going to rewrite this whole thing plugging in my variables. I started with an x to the 5th, so I'm going to drop it by 1. 2x to the 4th minus 4x cubed plus 5x squared minus 3x plus 9. All right. Because my remainder was 0, that means this guy is a factor of that equation, that function. And it means that -2 is a 0, in fact. It means that it will cross the x-axis or bounce off of it at -2, okay? So two things have happened here. I have figured out that that is a factor. That's true with division. If I divide 11 by 3, I will get a remainder. 3 is not a factor of 11. But if I divide 9 by 3, I do not get a remainder. My remainder is 0 because 3 is a factor of 9. That is also true with polynomials, okay? If you get a remainder of 0, it is a factor and it is a 0 of the equation. And this is your answer here when you do synthetic division. All right? One is that you can use synthetic division to figure out if it is a factor. It also tells you if you can plug in things and figure out what it is, right? And so your remainder represents what happens when you plug it in, which is why if you have a 0, then that's a 0 of the function, because if you plug it in, you get a 0. And so this is one of your remainder theorems, is that if a polynomial is divided by a binomial, the remainder is what happens if you were to just plug the guy in. All right, it's called synthetic substitution. Finding the remainder with the remainder theorem. All right, so synthetic substitution. If I want to figure out what happens if I were to evaluate them at these numbers, I can do this two ways. Evaluate, I could just plug those in. Good old-fashioned plug it in and figure out what it is. And so I could plug in a -4 cubed and do something like that. Or you can do synthetic division and your remainder is the same thing. So if I were to do synthetic division here, I would say x cubed, that's a 1, x squared, that's a 5, I'm missing an x, that's a 0, -4. All right? And I am going to do it by -4. Now, when it's synthetic substitution, you don't change the sign. They've actually handed you what they want you to plug in. You don't flip the sign when they do it like this. You only flip the sign when they give you a binomial, x minus something, x plus something. So now I'm going to do synthetic division with this guy. Add down, right? Multiply up, -4 times 1. Add down, -4 times 1. Add down, -4 times -4. -4 and 16 is 12, all right? This is my remainder. What does that tell me? That tells me what this would equal. -4 cubed, that's -64. -4 squared is 16 times 5 is what? Hopefully 80. It'll get me at the worst time here. So I have -64 plus 80 minus 4. My answer here is going to be 12. All right? That will always work. If you want to figure out what happens when you plug it in, you could use synthetic division. Synthetic division, this is what happens if you plug it in. So my remainder told me that if I were to plug in a -4, I would get 12. So if they wanted me to do that for all of these, I could just do the next row. And I could do it with a -3, a -2, a -1, and every remainder would be what happens when you plug it in. All right? Make sense? All right, try one. I don't want you to do all of these because we don't have time for that. Just do P of 2. Just do it with 2. I mean, obviously for something this small, you could plug it in, but I want you to use synthetic division to do it. So when you're using synthetic substitution, your answer is just your remainder. It is not asking you for the division of it. It's asking you what happens when it plugs in. I mentioned this a little bit. You can tell if something is a factor by getting a 0 as the remainder, because if you plug it in, you will get a 0, and if you have a remainder of 0, then it is perfectly divisible by that guy, which means he is a factor. And so then you can use that to help you factor the equation, all right? So they are telling me, here is your function, and I am going to give you 1, 0, which means you have a factor. All right. And since you have one factor, you're going to use that 0 to divide out and get it smaller. Once you pull a factor out, just like using a factor tree, you can then break the other one down smaller and break the rest of it down smaller. So if I were to have a factor tree for something like, I don't know, 62, right? Let's do 42. That'll be easier. So let's say I do a factor tree of 42. Well, I would say, well, I know 2 is a factor. That leaves 21. Well, if I want to break this down, I'm going to find another factor, right? And I'm going to be able to factor this guy here, something like that, okay? And so once you've taken out one factor, you can use the smaller piece and then factor him and get all the factors of something that you have, right? And so they've given us this, and they've told us this is a 0, which means if I were to divide this by 2 using synthetic substitution, I should be able to break it down into yet a smaller polynomial that maybe I can factor. So I'm going to use synthetic division here. I have it in standard form already. 1x cubed, positive 6x squared, negative 1x, and negative 30. They have told me this is a 0. So I am going to divide it by that 2. And since they told me it is a 0, what should my remainder be? 0. So if they tell you it's a 0, by the way, and you do synthetic division and don't get 0, you did something wrong. All right. So we're going to do synthetic division. We're going to add down 1, multiply up, add down, multiply up, add down. Lo and behold, we get a 0. That's what we were looking for. Okay. So we know if my 0 was 2, what's my factor? If my 0 is 2, what is my factor? What does your factor look like if your 0 is 2? Well, it's going to be x minus your 0, okay? So if my 0 is 2, x minus my 0 is a factor. What makes x minus 2 0? Well, 2. And they told me 2 was a 0. So if I have the 0, I can come up with a factor by just subtracting the 0 from x, okay? So I know x minus 2 is a factor. How do I find the rest of them? Well, I'm going to rewrite this guy as a polynomial. 1, I started with x cubed, so I'm going to say x squared plus 8x plus 15. Well, I mean, I could try to do synthetic division, but this is a quadratic that is factorable. Factors of 15 that give me 8. How do I factor this? X plus 5, x plus 3. So I have broken down this huge guy into 3 factors. My factors are x minus 2, the one they gave me, x plus 5, and x plus 3. If I were to FOIL all of that out, I should get the guy I started with, okay? If I were to distribute twice here, right, I should get the original function that I started out with. So those are my factors. I also know my zeros, right? So this is my factors. These are my factors here, okay? My zeros then would be what makes each one of these guys 0. They gave me 1. That's the 2. What's my next one? What makes this 0? -5. What makes this 0? -3. All right, so your factors will always be x minus the 0, okay? It will always be x minus the 0, okay? So you can use, they will give you 1 0. You can use that to divide it down and then do something that is factorable. So you can use synthetic division to factor a polynomial.